What exactly is the observable universe? The observable universe is the portion of the universe that we can observe and study using telescopes and different instruments. However, this ability is constrained by light, the principal source of information regarding the universe, which can only travel at a finite speed. As a result, all we can do is observe objects and events that are at a certain distance from us. We cannot directly see objects or events that occurred long ago in the past. The diameter of the observable universe is estimated to be roughly 93 billion light-years, which is much larger than the estimated age of the universe, 13.8 billion years. This discrepancy is because the expansion of the universe has caused objects that were once close together to move away from each other, and light from those objects has required more time to reach us. The observable universe is a vast and fascinating space, but there's still much we don't know about it. However, through the use of telescopes like NASA's James Webb Space Telescope and other instruments, we continue to learn more about the structure, composition, and history of the universe, as well as its various phenomena. Join us as we examine the brand new structures that the James Webb Space Telescope has recently observed in the far reaches of the observable universe. If you're interested in keeping up to date with news from the universe, subscribe to our channel. Make sure to subscribe, like this video, and hit the notification bell. Now, what lies beyond the observable universe? To reach the far reaches of the observable universe, we would need to develop transportation methods that would allow us to move beyond spacetime, like using distortion engines or wormholes. These concepts have been the focus of discussion among scientists, some of whom believe that these are simply impossible or refute the notion of faster-than-light travel. The feasibility of both possibilities, faster-than-light travel and the use of advanced technology, is beyond the reach of current human intelligence and is a subject of intense debate. Even if it were theoretically possible, it would require technological advances and machinery that are currently beyond our capabilities. Theory of cosmic inflation, the total size of the universe is at least 1,023 times larger than the observable universe. This number is so vast that it is a mystery to the human mind, since we cannot see or measure the unobservable part of the universe. We lack the ability to know with certainty what lies beyond its limits. However, this does not preclude us from developing theories based on the data we have gathered from distant galaxies. NASA plays an important role in this effort. NASA, working together with other space agencies and research institutions around the world, has made numerous significant contributions to our understanding of the universe. Even before the James Webb Space Telescope launched this year, NASA had already released images of the ultra-deep field obtained with the Hubble Space Telescope. However, when the James Webb Space Telescope made its debut, it observed the most distant galaxy ever recorded. These images revealed the presence of numerous galaxies shining in the distant cosmos, appearing just a few million years after the Big Bang, circa 13.8 billion years ago. The expansion of the cosmos causes the light to appear at redder wavelengths, which allows the James Webb Space Telescope to detect infrared light. This has enabled us to observe galaxies forming in the early stages of the universe's history. The James Webb Space Telescope's observations of several fields of distant galaxies allow scientists to study the rate at which stars formed in the early universe. This data reveals the presence of a sizable population of galaxies that were forming stars in the early stages of the universe. These findings are truly fascinating and thought-provoking. For a long time, humans have contemplated the possibility that we are not alone in this vast universe. However, these new observations within the observable universe lead us to believe that there must be millions of galaxies in the unobservable part of the universe. This concept is truly shocking and inspires a sense of awe. Vastness of the universe. Is there extraterrestrial life somewhere in the universe? The likelihood of life beyond Earth has never been more compelling, causing us to think about the possibility of the existence of extraterrestrials. Numerous planets outside our solar system, called exoplanets, have been discovered through methods such as the transit method and the radial velocity method. Some of these exoplanets may have characteristics similar to Earth and may harbor life. This idea has been supported by another discovery made thanks to the James Webb Space Telescope related to WASP 96b, an exoplanet. This planet, which is not part of our solar system, has a light spectrum that reveals something unexpected, the presence of water molecules. In addition, the spectrum also shows hints of haze and clouds, which were not previously thought to exist on a habitable planet. Based on the discovery of habitable environments elsewhere in the universe and considering the advancements in the search for exoplanets, it is difficult to rule out the possibility that alien beings exist outside our planet. Although we do not yet have conclusive proof, these discoveries and evidence suggest that the existence of extraterrestrial life is a fascinating possibility. What about the multiverse? In relation to the vastness of the observable universe, let me tell you, the possibilities are endless. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea in physics and philosophy that suggests multiple parallel universes exist or dimensions beyond our own. The multiverse is mainly discussed in the context of quantum physics, which deals with the behavior of tiny particles such as atoms and subatomic particles. According to some interpretations of quantum physics, the act of observation can destabilize a quantum system into a single state. However, in the many worlds interpretation, the act of observation simply causes the system to divide into several states, with each representing a different outcome. It is important to note that the idea of the multiverse is still very speculative and is not yet supported by conclusive evidence. It is, therefore, difficult to state with certainty whether it is a valid concept or not. Some scientists and philosophers find the idea of the multiverse intriguing and potentially useful in explaining certain phenomena, while others are skeptical about its validity. Given that we do not know what lies outside our universe, the possibility of a multiverse remains valid. The famous Schrödinger's cat thought experiment or the nature of darkness also sparks fascination. It is a concept that arouses fascination and reflection but requires more research and evidence to be confirmed. Does the phenomenon known as dark flow exist? The query is nuanced and raises a fascinating problem. Dark flow emerged in 2008 as a possible explanation for the observation that some clusters of galaxies appear to move faster than expected based on the distribution of matter in the universe. The concept of dark flow suggests that these clusters of galaxies may be affected by some form of dark matter or dark energy that draws them in one particular direction. However, the existence of dark flow remains controversial and has not yet been accepted by the scientific community at large. Some studies have suggested that dark flow may be real and could be caused by the presence of a universe-wide massive structure that exerts an attraction on galaxy clusters. However, other studies have failed to confirm that dark flow exists and have suggested that the observed motion of galaxy clusters could result from additional factors like systematic errors in the data. While some studies suggest its possible existence, we cannot state with certainty its presence outside the observable universe. More research and evidence are needed to better understand this intriguing phenomenon. What do you think? Please inform us via the comments section. Remember to like and subscribe, and see you in the next video. One of the greatest mysteries in cosmology is the nature of dark energy and dark matter. Together, they account for roughly 95% of the universe, with dark matter accounting for approximately 27% and dark energy making up the remaining 68%. Despite their significant impact on the structure and evolution of the cosmos, we have yet to directly identify either of these obscure components. The prospects for our understanding of the universe are bright, and every discovery opens up new avenues for questions. The universe, with all its vastness and complexity, is a testament to the wonders of scientific exploration. Whether that means uncovering the mysteries of dark matter, detecting signs of alien life, or exploring the very fabric of spacetime itself, understanding the universe will likely continue to shape human history for future generations.